And I hope you'll find it interesting, and I'm sure you'll have some questions here. My name's Pat Jamieson. I'm a physician, but also a developer with a lot of experience in a lot of areas related to medical informatics. What I'm going to be doing this afternoon is talking a little bit about the plumbing of FHIR. And my colleague, who's far more experienced in InterSystems technology, Mark Massias, is going to show you a wonderful demo of the analytics after you've done the plumbing. Why FHIR Analytics? Because FHIR is truly growing by leaps and bounds. With the federal government behind it, we know that we're going to see a lot more FHIR apps in the future. Data is going to be mandated to be accessible through FHIR. And so, given that, I think there is no doubt that FHIR is going to have a huge impact in the medical IT community in the coming years. What I'm going to focus, though, on right now is the idea of FHIR as a data model. This is something that's a little bit controversial in the sense that FHIR wasn't really conceived per se as a data model, but given how much data is going to be collected through FHIR, I think it's going to wind up that a lot of the elements in FHIR are going to be mined in a lot of different applications like decision support and analytics. So here's my quick agenda. We're going to do a very quick FHIR review. We're going to understand some of these obstacles to doing FHIR analytics. I'm going to give you a demo of some code I wrote that is a FHIR production that will process FHIR bundles so that we can do analytics on them. And then Mark's going to do a great follow-up of analyzing those resources using IRIS Business Intelligence and Power BI. At the outset, this is a session where we're really looking for your feedback. This demo uses prototype code. It's not in production. We're using FHIR R4, which will be available in 2020, the first quarter. So we want your input and feedback, and that's why we have these questionnaires, to understand your FHIR experience and where you want to go in terms of the FHIR roadmap. So we'd really appreciate you filling these out, and you could do it at the end of the session if you want. FHIR is organized along the lines of the concept of a repository. So this is probably something that is familiar to any of you who've done anything with FHIR. You have a base address that identifies a FHIR system service, and then you have a type that describes mainly a FHIR resource and some kind of identifier. And so if you store information in FHIR using this format, you can pull data back, usually as XML or JSON. FHIR has over 100 different resources representing widely different types of content. So here's an example. Here's a patient resource. And I think, I can't say enough how good I think the FHIR documentation is. If you haven't seen it online, you should. It defines the schema of FHIR really very, very well and in great detail. So the patient resource here, you see the word N, the letter N, it's a normative resource. We'll talk a little bit about that. And you could see it has either 0 to many identifiers, 0 to 1 Boolean for the active property, and so on. What that so on, though, is we have to clarify, there are a lot of different data types in FHIR. So we have this concept of a resource, but we also have a lot of these resources with properties that essentially have their own FHIR types. They could be primitive types, general purpose types, metadata types, and special purpose types. FHIR is a very extensible standard. It follows the 80-20 rule, but you could extend it if it doesn't incorporate the kind of data types you're interested in capturing. So what does that normative mean? Right now, many of the FHIR resources are being refined, and only 2 of them have reached the state of maturity that we would call production ready. That's the patient resource and the observation resource. However, in the next year or so, 20 to 25 of those resources will become normative, which means you could rely on them in a production system. FHIR really creates some opportunities beyond SDA. SDA is not going away. They're both standards for exchanging information, but FHIR encompasses many more resources. Both of them can be extended, but as InterSystems looks to the future, it looks increasingly that we will be incorporating FHIR as a data model in our designs. The FHIR data model addresses common use cases and unfortunately at times could add a bit of complexity. For example, the patient resource can have multiple names, and each of these is a separate FHIR structure. Every resource, though, can be defined in ObjectScript easily as a corresponding class. Some of those classes have properties that are closed value sets. Others have open value sets. And when they're open, normally the type of data type we have is a codable concept. So what are the obstacles? Well, one of the obstacles is that this is not a flat data structure at all. It's not the kind of table that a data scientist would normally mine. So we have objects that embed things like arrays, other objects themselves, or have links to other structures. So if you're going to persist these, not just exchange them, but persist them, we would like to convert some of those array properties into additional tables, where each table captures an object that is being described. So I've used the array property versus the list property, which would just give us a single column. One FHIR class can correspond to multiple tables, and one table can have multiple classes. As I've built this demo, just to capture the FHIR and observation resources, I needed about 120 tables. Why? Because there are a lot of FHIR data types under the hood that you need to be able to capture. The good news is that you can do this fairly easily using IRIS. It's a multi-model database. It makes it easy to project objects as tables, and that's what we want for analytics. But we need to go a little bit beyond just capturing those tables. We got to think about, when we do analytics, what extensions do we want to capture? Do we need to encrypt any sensitive data? That's a transformation, but a transformation very easy to do. Do we need to transform any of the fields, and how can we best denormalize the data? I've created, in using this demo, I needed data. I don't know how many of you are familiar with Cynthia. It's a great open source synthetic FHIR generator. You could generate high quality patient data. It's open source, and it allows you to generate synthetic data in either STU3, DSTU4, or R4. And so we've generated data that you'll see in this production. Additionally, you can model diseases using Cynthia. I'm not going to go into the specifics here, but here's an example of making a disease dealing with obesity and modeling how many values or percentage of values you get from different parts of the population. So the big picture in terms of modeling, what do we need to do? We start off with capturing data. This is the interoperability stage or the data preparation stage where we take those FHIR bundles in, we convert those to dynamic objects, and then we need to capture them as true FHIR objects using our R4 schema. But that's going to generate a lot of raw tables, and that's going to be difficult for a data analyst to mine. So we need to create derived objects that roll up or denormalize this data to make it easier for our analysts to mine. And then we have to do data cleaning and data visualization, and Mark will show you that. So I'm going to give you just a quick high-level view of the production. It takes data in from a directory. That directory we could feed in FHIR bundles. It'll be processed through a business process layer that'll break those bundles apart and look at whether we're dealing with patient or observation resources and store them. If it's able to store them correctly, meaning no errors in the structure, it's going to create derived objects that we could use for analytics. And here's kind of the flow of that, the business process workflow. And I'm not going to belabor this here. If this works, when it works correctly, you're going to see raw data. This is one of the raw tables from the FHIR schema. As you could see, you're going to get references to other objects, like marital status, 22. Well, what does that mean? Well, essentially, that is a reference to another object in the codable concept table. And that's why we need to roll this up, because obviously we couldn't really do analytics on that data. We can also do transformations. So one of the things I built in the code, in building the derived table, is looking at different extensions that we want to capture and rolling them into properties such as ethnicity, race, etc. Once that's done, then you can have a derived table that makes it much easier to mine. So you can see specifically ethnicity, gender, language, etc. And this is just a quick demo or a quick summary then in using Power BI of using that disease modeling of using Cynthia for obesity and how I pulled that data out of the derived patient observations and filtered it for this. So let me show you the demo. Go into Visual Studio Code here, and as you could see, I have a bunch of containers that I could run. Currently, I have the IRIS for Health container running here, and I'm going to just pull that up here. I'm going to open the management portal, and we could then look at, let's take a look at this production. So we see the different parts of the production that I've already shown you here, and its connections in this production. Now what we'd like to do is run some data through it and see if we could capture that data. And so I'm going to go and look for some patients that have been generated using the Cynthia program. And I could see I've generated over 100 patients here. We're going to select, let's select about 10 patients or so. And we're going to copy, actually we'll copy these 15 items. And then we'll go to our IRIS for Health container that's running. And we're going to just drop that data into the input directory. And as you could see, it's going to start to process these fairly quickly. Now we go back to our production. We could take a look in the queue. Let's see, good the level of queue here. We see we have quite a few things remaining in the queue here. the reason we have so many items in this queue is because one patient could have many, many observations. So think of all the lab values, et cetera. Let's see, we are beginning to really, okay, so we've processed now all of that data. We've generated all those tables and captured all the data, but we really like to see a little bit more in terms of, if we go to our message trace, we could see that if from our storage layer, if it's correctly stored, we'd get basically a derived object that then we can do mining on. So let's just take a quick peek at that. What would that look like? If we go back to our System Explorer, we take a look at the SQL. I'm going to just expand the number of tables here. And you can see there's quite a few tables that make up, breaking out all of this FHIR data. So I'd like to take a look, let's take a look then at our derived observations and execute on this. And you could see the kinds of data that we're getting here. So anything from, these codes are generally LOINC codes, from pain severity, which is a score, to body weight, body height, and there can be multiple values for any given patient, diastolic pressure, et cetera. Let's take a look at the patient, derived patient resource. And executing on that. You can see we capture the patients and their marital status, ethnicity, et cetera. So basically, this, in sum, we've created a production that could take in FHIR bundles, separate them into resources, project them as tables, and then derive a kind of a denormalized table that you can do analytics on. And at this point, we're ready to basically use analytic tools to do all kinds of visualizations. And I'm going to turn it over to Mark, who knows a lot more about that than I do.
Okay, so we're going to, thanks Pat for that, it's really helpful. So what we're going to look at now is how do you deliver analytics on top of FHIR. So what we've seen is the fact that you can create a persistence mechanism for FHIR, which is all well and good, but the FHIR model itself is fairly complex, so you need to flatten out that FHIR model in order to be able to deliver analytics on top of it. So what I'd say is basically this concept of derived tables is key to delivering analytics. In order to deliver analytics on top of the raw FHIR object model would be very difficult to do. And then you have options. So you have choices in terms of what you can do. You can use IRIS Business Intelligence, which is an inbuilt analytical capability within IRIS, which is based on a product called DeepSea. A quick show of hands, how many of you are familiar with DeepSea? Okay, so about half of you have seen DeepSea, so that'll be quite familiar because it is, in essence, very similar technology. But then you can use other tools as well. So you can use other business intelligence tools such as Tableau, ClickView, JReport, so on and so forth, using XDBC, so using ODBC and JDBC to access that data directly. But more recently, with IRIS 2019.2, we built a native connector for Power BI. Power BI is a Microsoft business intelligence tool. What does a native connector mean? Well, I'm going to show you. In essence, it means that it can interrogate the cubes directly and read the metadata based on the business intelligence cubes. Okay, so let's dive in now to look at how do you go about delivering analytics on top of the data that Pat's put together. So you can switch me over.
Yeah, he's going to switch over now.
So quick show of hands, who recognizes this as a product? So in essence, the same people that said they were familiar with DeepSea. Okay, so this is a component of IRIS Business Intelligence, a product formerly known as DeepSea. which is called the architect. And the architect is where you build the models up. This is where you build the multidimensional models. So you've got two areas within the screen over here. You have the left-hand side, which is the source data, and the middle pane over here, which is the model itself. So the process of building a model is merely a matter of taking these fields within the source data and dropping them in either as dimensions or as measures. So this is derived observation. So this is one of the derived classes that Pat was talking about. There's another one called derived patient, okay? And there's a link field over here, PT resource ID, that allows me to link an observation to a particular patient, okay? So this could be done in a slightly different way. This could be done through an object-class relationship between derived observation and derived patient. But in this case over here for the demo, we just put it together as a field that links both of the classes together. Okay, so what do we have over here? So the default measure is a count. And in this case over here, it's going to be the number of observations, so number of blood tests and sodium tests and so on and so forth that have been done. And then we have different dimensions. So we have an observation date dimension, which is based, you can see over here, on a property called issued. Okay. And the issued property over here appears in derived observation. And this is the date that the observation was issued. Okay. Now, so Deep Sea and IRIS Business Intelligence is time aware. So you can feed it with a date or a timestamp data type, and it will understand that it's a date field, and then give you the ability to build a hierarchy. So what I've done over here is I build a hierarchy for year, month, and day, so I can drill down in terms of analysis. Yeah, and you can see this is delivered with these functions where I can draw it through to year or week number, quarter number, and so on and so forth. And this is all part and parcel of IRIS BI. So that's the date. Then the observation is actually the name of the observation. And this is delivered from a field called code display, which appears over here. Okay, and that's going to be HbA1c, sodium, systolic blood pressure, that type of thing. Okay, and then gender, age, and patient are dimensions that relate to the patient, which, as I said, is linked through with PT resource ID. So the way I deliver these, for example, gender, is I've created a utility method in a class called Derived Utils, which will all be available on GitHub for yourselves to be able to download and look at, and a method called getGender, where within the method called getGender, I specify the source.pt resource ID. So this field over here that allows me to link the observation through to the patient. I do a similar thing with the age of the patient, other than I add an extra thing, which is what is known as a range expression. So instead of having a dimension that gives me ages of patients, 1, 2, 3, and so on, this brings it into buckets. So I have between 0 and 19, it will be displayed as 0 to 19, 20 to 39, so on and so forth. And this is, again, this is part and parcel of IRIS BI. For the patient name, I do a similar thing. I use my class over here, Derived Utils, and a method I've built called getName, which allows me to get the name of that particular patient. Okay, and then I have what are known as detail listings, which gives me the ability to look at from the data in the cube directly through to the underlying transactional data, and that's one of the key capabilities of IRIS BI. So this is a class, so I can go ahead and compile this. This is running on top of IRIS. Okay, so that's the class compiled now. And then I can hit the build button. And what the build button does is it takes all of my source data in terms of my derived observations and my derived patient, and creates an indexed cube, which is then accessible through IRIS BI toolsets and also Power BI and other products as well. So you can see over here it's built a number of facts within that cube. Typically you wouldn't do this. Typically you would build the cube in terms of changes to the source data. This is basically saying rebuild this cube from scratch. Okay, so that's the cube built, and then I can start to use a tool called the Analyzer within BI. And the Analyzer then allows me to take the model, which consists of a number of dimensions and a number of measures, so a number of observations, the value of the observation and the patient count, and drag them, drop them into rows and columns, and be able to visualize the data in different ways. So for example, I can take the observation date and drop it into rows, and this is showing me the number of observations are performed over a period of time. It could be I want to view this as a bar chart, so in which case I just click on this button. It shows that data appearing in bar chart format, so you can see the number of observations year by year, and I can also view both of them at the same time. More importantly, what I can also do is I can take this data and say, let's get rid of this and let's put in my observation now as a filter. And let me put in my patients in the rows, okay? So this filter observation allows me to select the particular observation I'm interested in. So I can go into this very quickly, and you can see there's a really big wide range of different observations coming into this. So if, for example, I want to do an analysis on hemoglobin A1C, HbA1c, which is a measurement that's done on diabetics, to look at typically their average blood sugar level, I can go into this and put in a search term for this, hemo, and then say hemoglobin A1c is the one I'm interested in looking at. And then I can go in and then start to rank this. But instead of looking at number of observations, I might want to look at the value of the observation itself. So what I do then is I take my value, drop it in as a measure, and this is now showing me the average value for individuals. So you can see Gabriel Jones over here has got an average value over the years for every single observation that's been done for that individual of 8.11, which is quite high, okay? That's not usual, but it is usual if you're diabetic, but it's not usual for the population. And then I can say, okay, let's look at Gabriel Jones' HbA1c over time. So I can take that, drop that into Gabriel Jones. So now I'm filtering on Gabriel Jones, and I can do a chart to show me his HbA1c was fairly static for a number of years. Then in 2015 went up. Then I'm assuming some intervention came into place, and then it moderated itself. Okay, so very, very quickly you can deliver analysis on top of FHIR data by building a cube within IRIS Business Intelligence. So let's look at some of the ones I built already. So you can save these pivot tables, so then you can go and view them. So this one over is looking at body mass index by age group. So I can look at different age bands, number of patients within that, and then the value of body mass index. And again, I can do the same type of thing. So if I'm interested in the patients between 60 and 79, I can take the patient, drop it in, and then it will break that down into the individual patients that fall within that particular age band. Another pivot table I put together looks at systolic blood pressure. And this ranks the patients according to their systolic blood pressure for time period now, which is the current year. Okay, so this would show you which patients have got very, very high blood pressure and then be able to deal with them. Okay, so beyond that, there's also dashboards available within IRIS Business Intelligence. So a couple of examples over here, an observations dashboard. So this is looking at the same type of data we looked at already. This is number of observations over time, and then number of patients over the years with the ability to filter. So I can go into this, and if I'm interested in looking at the number of sodium results that have been conducted over years, I can go in and select sodium, and now it's showing me the number of sodium observations done over the years and the number of patients that have been tested for sodium over those years as well. Another very simple example of a dashboard is this one over here, which is merely looking at, not this one over here, but let me just go back. This dashboard over here, the patient dashboard. This is now looking at number of patients across different age bands and by gender. So I can very quickly see that most of my patients are female and in the age range of 40 to 59. And IRIS BI gives you a large number of widgets. These are two different widgets over here, but I can drop into the dashboard. So to give you a little example of that, Within this, we have a really wide range of different types of charts. Then there's a widget called a scorecard, which allows you to embed different visualizations within columns, like plot charts and so on and so forth. And there's a bunch of meters, like speedometers and so on. And there's even a Google Maps API. So if you have coordinate-based data, you can pump that data into this widget and view that data in a Google Map. Okay, so that's what I've shown you over there is creating a model with the architect and then analyzing that data within the model with IRIS Business Intelligence. What I'm going to show you now is doing a similar type of thing but with Power BI. Okay, so this is a Microsoft tool, which is a very dominant BI tool out there, in conjunction with tools like ClickView and Tableau. And with Power BI, we've developed a native connector for IRIS. What does that mean? That means the following. So if I go into Power BI, this is Power BI, and I say get data, which is the way I'd link it through to a source of data, it now gives me on the right-hand side over here a really wide range of different types of databases. So all the usual suspects and more. So loads of relational databases, loads of cloud-based databases like Amazon Redshift and Azure SQL database and so on, multi-dimensional databases like Essbase. And from within here, I could go down there, I could do a search on IRIS. And you'll see the IRIS, InterSystems IRIS appears as one of the sources of data within that range. So I can connect to this and fill in some connection parameters. So I'd have to put in the host address of where the IRIS server is located, which fortunately happens to be my machine, which makes it easy. And then specify a port, which would be the super server port for those of you familiar with the IRIS and preceding technologies. I specify the namespace, FHIR Analytics, that's the name of the namespace, and then I connect through to this. And this now shows me not only tables within my database, so even all these will be basically the FHIR persisted data, and also the derived tables within that, so there'd be derived observations and so on, but it also shows me the cubes. Yeah, so it accesses the IRIS Business Intelligence cubes, so and many of you will be familiar as deep sea cubes, and it shows me the underlying tables. So there's a fact table and a number of different dimensional tables, and I'm able to select those and load them into Power BI. And what that does is it creates a cache of that data and also creates a model for that data as well. And it's clever enough to be able to figure out what the relationships are between those different entities. So if I look at this, for example, it'll show me that at the core of this, I have a fact table and it has a number of different dimensional tables. Okay, so I've created a Power BI report based on that, which is this. So I can go in and refresh that data. So this is now going to my IRIS BI cubes and drawing the data. And with this visualization, I can go in and drill down into data. So I can go and select drill down. Now I'm going down to 2015, down to Q3, down to August, down to the individual dates within August. It gives me a large range of visualizations, and if I'm not happy with the ones I find over here, I can download extra visualizations from the marketplace as well. The filtering is very easy to use, so if I wanted to create this but be able to filter it, filter by, for example, observation, all I'd have to do is pull this observation, drop it into a filter, and then I'll be able to filter according to that particular parameter. And then on this pane over here, what I've done is I've created a report, which hopefully you can see, that's filtered for HbA1c. So this is looking at the patients where their HbA1c observation is greater than 6. You can see the filter over greater than 6. And lo and behold, Gabriel Jones over here appears as being the the patient with the highest HbA1c. Why? Basically because we're delivering exactly the analysis with different tool sets, but based on the same data. So the data resides within IRIS-BI. Okay, so what we've seen over there is building the cube, being able to analyze that cube with an inbuilt business intelligence tool, which is IRIS-BI, and also being able to do the same type of thing with Power BI using the native adapter. Okay, so on that note, I'd like to hand over to Pat.
Is that FHIR offers a way that'll make it easier for people to extract data from electronic medical records. These records, we believe, will be much more open in the future because of essentially our federal regulations that will require the openness. And I anticipate that a large number of startup companies and a large number of interested individuals who are doing analytics and decision support will take advantage of this. But additionally, FHIR is a rich data model in and of itself. The HL7 committees putting together FHIR have given a lot of thought not only into the structure of FHIR, but its semantics. So I believe that their insight and their continued work on FHIR will produce an open standard that we could all enjoy. I think also, and this is a little bit of projection, FHIR is going to overtake HL7 V2 at some point. It may take a decade, but it is gaining tremendously in momentum. But if we want to do analytics on FHIR, we're going to have to do some amount of preparation and cleaning of that data. As good as that data is, getting back a big JSON payload will not help your data scientist. But the good news is that IRIS is really designed to capture this type of data and exposes it as tables with additional then work and transformations that can be definitely made as a great data source for doing analytics. And as Mark has shown you, we have really good tools within the IRIS platform in the form of business intelligence that are integrated right into the platform to do visualizations and to build cubes on this data. But for those that are more familiar with Power BI, you have other alternatives. You're not just limited to business intelligence. So that's kind of our quick summary. Again, we're very interested in your feedback, so please fill out these questionnaires. It's going to help us in planning our roadmap. And with that, I'll open it up for questions.
So are you going to build APIs for the analytics so we wouldn't have to use another software package to do more nuanced
So are we going to build,
reports, and so we can, let's say, embed
So did he say KPIs or?
APIs.
Repeat the
APIs.
question, Mark.
Yeah.
Just repeat the question for.
So the question, I guess, is are we going to build APIs on top of this to make it easier for yourselves to deliver analytics on top of this? Is that the question, I guess?
Say
Yeah.
you have a web page and you want to say how many patients you saw every day. Could you pull the data out of analytics into?
Yes, so all this data is available through APIs. So there's definitely APIs that would allow you to interrogate this and deliver that. So are we going to add extra richness to deal with FHIR? That's a slightly different question. But in terms of being able to access the data through standards-based APIs like REST and web services and SQL and so on, that's definitely out of the box.
Thank you.
No, thank you.
Yes.
Any other questions?
What's your best use case for data cleaning?
Well, I think there's a lot of steps in data cleaning. And, I think it depends a little bit on the use case. But as you know, in the HealthShare platform, there are tools within the platform to deduplicate data. So data coming from different sources that may have effectively different IDs but refer to the same patient. That deduplication is part of data cleaning. But you also have things like normalization of data. So if you have data using different code sets, normalizing them to a single code set is critical. But there are other steps in data cleaning as well. So things like, for example, checking for outlying values is part of data cleaning. Looking for data that essentially may not fit within your common sense effectively, that these data can't exist. So there is no magic tool. There are a number of tools, though, that can help you get there. HealthShare has some of the most common and important tools to do data cleaning. But really, this is a job that data scientists do day in, day out. They have to know. No one can really do analysis of data without having a certain amount of domain expertise and understanding the character of that data. That's critical to cleaning it. But once you understand those things, the tooling that we have through business intelligence, Power BI, things like that, make it fairly simple to clean the data if you know what you're doing.
Thank you. So I asked my question through the app, but I guess I probably have to voice it now.
Yeah.
My question was on the derived tables. I didn't get a chance to see whether they have indices, and I'm wondering how does performance get affected if you're dealing with a large data set, like hundreds of thousands of patients?
Yes, that's a very good question. This proof of concept was not built to be a scalable production system. Okay, so that would be clearly something you would absolutely need to build into the way you capture the data to make it scalable. That would be the step number one. There would be a lot of other things you could do to improve scalability. But my concern really in building this POC was just to get feedback, especially from this audience, of whether FHIR Analytics was something that they even were interested in. So yeah, your question is highly appropriate. If we're going to do this for real at scale, we're going to need those indices, obviously. Well, then I really thank you for coming, and again, give us your feedback. We're very interested in your ideas and anything we could do to improve the roadmap for FHIR. Thanks.
Thank you.